Hello, I am Atai from the RoboRoos East FLL team. Today we will be putting together what we've made so far into a working XY movement, as well as going through something that will make life a lot easier to use this program in the future. All you need to make the XY movement is a wanted direction block and a wanted distance block, followed by directional move. Then all you need to do is put compare for less than or equal to. And so this compare will function pretty much the same as turn to, but instead of giving a range of how far off you are, you can instead find the distance to your wanted point using wanted distance, as wanted distance will always be positive. So now all you have to do is put in a loop, and grab these and put them inside. Set the loop to logic and plug in the compare. And then outside the loop you just want to put a break routers. And so now just select this and turn it into my block. Call it move XY. And then give it 4 inputs. The first input's going to be X, the second input Y. The third input is going to be accuracy. And what this is going to do is, because the robot will never be perfectly on the point, we need to give it some leeway. And that's pretty much why we've set the compare to less than or equal to instead of just a solid number. And the last one is, of course, speed. And so now just give them appropriate icons. So X, Y. And we use the symbol for accuracy. And of course speed. And for this icon we just use the typical motors. So once you've done that, just click finish, and then just plug the X and Y into both the wanted direction and wanted distance. And don't forget, when you go into a loop you can actually take this tab and it will have the same value as inside of the input. And just do the same for Y. And now what you want to do is, for wanted direction, you want to put it into the direction that directional move is going to go, and wanted distance you want to put in the first compare slot. In the second compare slot you'll want to put the accuracy, and in the directional move empty slots you'll want to just put speed. And there you go, you've got a working move XY. Don't forget you do have to initialize some variables, and so what we're going to do now is just make that simpler. Okay, so now I can start on that. So what you'll want to do is, it's something that's both a convenience and a necessity, especially if you're going for an efficient program. And so we're going to start on what we call init run. And this block, while having no real effect on how the robot moves, is incredibly helpful and makes the code a lot easier to deal with. So essentially all init run is a block that we run at the beginning of each of our runs that resets the robot completely, the motor encoders, the sensors, the tracker, and anything else that might affect the run. The reason we do this is that we might have a different starting position every one, and it's also convenient to just have it all in one block instead of copy-pasting a huge amount of code. And so later, in the next few episodes, I'll talk a bit more about all this, but for now I'll just make the demos. So all you have to do is, for example with the sensors, you grab any sensors you might have on the robot and just set them to reset. And you'll also want to do this for all of your motors, so especially your movement ones. However, you might also want to do it for any attachments or things that you think you might be using. And so you just do this with all of your sensors. The next thing you'll want to deal with is variables. And so you'll want to set X lost and Y lost. For now, it doesn't matter what the numbers is, but essentially what happens is you might want to start the robot at a different position. And so for that, you might want to change these values, because the whole point of the tracker is that you have the same grid every time. And so that means that we want the grid to start from the corner of the mat. And so the way you'd do this with the robot is you'd measure from the inside edge of the walls to the center, to where the center of the wheels is, and you'd get the X symbol of that, and you'd plug it in here. And so we're going to make inputs in init run for these two. And now you'll also want to do the same to last distance. And this is just to initialize it, because if you don't initialize a variable, it sometimes encounters trouble when you try to read from it. Yep. So this is going to be everything in the my block. And so, for example, things like the tracker, you'll want to definitely put outside of init run as it runs infinitely, so the my block wouldn't get out. But also, because you want to run this at the start of every run, not at the start of your actual program, we're not putting in gyro reset or anything fancy like that, because that will just sacrifice time when a perfectly normal reset will do the same thing. So we will be building on this in the future as we add more things, but for now, just turn it into a my block and call it init run. And then give it, well, you can give it any icon, but we give it this little briefcase symbol. And you want to give it two inputs, first being start X, and the second being start Y. And let's click finish, and all you need to do now is just plug the X here and the Y here, and you're done. And so at the start of all of your runs, not your actual program, but your run, you'll just want to put this, and then depending on where you start in regards to the corner of the mat, you just set the variables from an init run. So you could start like 2020, and then you could measure all of your movements from the corner of the board. And so yeah, it's also a lot more efficient because you don't have to put all of the variables and the resets every single time you start a run, and it can make things a little bit more accurate and smoother to work with. And so that's pretty much it for today. So thank you for watching, and see you next episode.